Before I continue with the assembly process, I want to zero all the servos so I will know that they're at the right positions and I can tighten them in place. This will make the continuation of the assembly much easier. So I skip some of the assembly steps and jump directly to the step where we zero the servos. For this, I have prepared Visuino code to zero the servos, and now I'll connect the controller to the computer, disconnect all the servos, because they are highly likely to jerk, so I don't want everything to start jumping while zeroing. So all the servo axles are now disconnected and no parts are going to suddenly jump. And now I'll go ahead and upload the code. First, we'll need to select the board. The robot is based on the Node MCU board ESP8266. Next, I will add the chute. It is the Acebott Quadruped Bionic Spider chute. Now added to the board. And now we can see the chute here in the properties. I'll expand it to access all the settings for the servos. Now for all of the arms, I will set a initial value of 0.25. First arm, second arm, third arm, and the fourth arm. Next, I will set 0.75 as initial value for the pulse. I'll copy and paste it for all of them. And our project to center the servos is ready. Now I can go to the Build tab, select the port where the robot is connected, and click on this button to compile and upload the code. The code is compiled and now it is uploading. The code is uploaded. and I can disconnect from the computer. Now, to power the servos, I need to install a rechargeable battery. This one is already charged. I need to make sure that we are in the off position, and I'll go ahead, make sure plus here matches the plus with on the battery, and the minus matches the minus. Insert the battery in place, and now I can go ahead, power it on, and see if the servos will zero. And indeed, all of the servos have zeroed. Now I can install all the parts as shown on this picture. So this will have to be exactly like this. This like this, as close as possible to perpendicular. So this is the closest I can do. It's never going to be absolutely perfect, but I try my best. This one like this, as horizontal as possible, as shown on the picture. This one like this. This one like this, horizontal. This one like this. Try to find the closest to perpendicular toward the robot. This is the closest I can achieve. Finally, this one. It's a bit too much on the angle. Let's try again. See, no, this is bigger angle, so this is the closest we can do with this particular servo. Yes, I mean the servos are not perfect, so there are some variations, but as long as it is within a degree or so, we probably are fine. So this is the closest I can achieve. I'll power it on to make sure I have not moved the servos significantly. This one really looks off. I will try one more time to see if I can adjust it and make it more horizontal, but that's probably the best I can achieve with this servo. This guy is a bit loose, so this looks, is this better? Not really, it's really in the middle, so I have to decide, do I want it a little bit up or a little bit down? A little bit. This one is probably the better of the two options. Yeah, this is the closest to horizontal I can get. So that's the best I can achieve at the moment. In any case, as you can see now, the robot is centered when powered on. All the servos will take the center positions, and it will look roughly as shown on this picture. This is the closest that I can achieve. This step is completed, and I can continue assembling the robot.